Hi students, good morning. Now we are going to learn division lemma or Euclid's division lemma. For that, let us consider one situation. A person has some gold coins. All his gold coins arranged in the form of a square area on a table, and also for the security purpose he arranged a security guard, and he thought that his gold coins are safe. But when he returned from the office, he found only two gold coins on the table. He inquired the security guard what happened. Then the guard replied, three thieves came, they distributed all the gold coins equally. So because two coins are left and because they couldn't be able to divide them, they left the coins. The person was thinking whether the God, what he is saying is truth or not. How do I come to know about? Then let us try to solve this problem by using division lemma or Euclid's division lemma. So first let us try to understand what is that. Okay, now we have 13 flowers which are to be arranged in flower parts. So when we have two parts, all the flowers are to be arranged, means 5 flowers can be arranged in two parts and 3 flowers are left. On the other hand, if we are considering like 13 flowers, but instead of two parts, suppose we have 3 flower parts, then what happens? Each part contains 4 flowers and 3 parts are there, so 4 into 3 plus 1, right? Same 13 flowers, suppose if we consider 4 flower parts in which they are to be arranged, we get 3 flowers in each part and 4 flower parts, and 1 flower is left even in this situation. So the same thing we can write it like 13 is equal to 3 into 4 plus 1. In the same manner, suppose we have some flower pieces, diamond shaped pieces which are to be arranged in the design of flowers. If we take 4 pieces for making one flower design, we get 3 designs. So 4 into 3 plus 1. Instead of 4, suppose 6 pieces are used for making each flower design, then we get 2 flower designs and 1 piece is left in this situation. Okay, now let us consider few more general examples from our daily life. Suppose we have 4 ball pens in each packet and we bought 5 packets and 1 pen extra. Then what are the total number of pens we bought? 21. So 4 into 5 plus 1. In the same manner, suppose if we buy erasers, right? Each packet contains 3 erasers, 4 such packets and 2 loose. So 3 into 4 plus 2, total 14 erasers. Likewise, you can see pencils. Each packet contains 15 pencils and no separate pencils are there. So we can observe total pencils bought are 45. And likewise, if you consider now each packet contains 12 sharpeners, but we did not buy any sharpeners separately, only 5 sharpeners separately we bought. So we can observe that 5 is equal to 12 into 0. Though the packet contains 12, no packets are bought, so 12 into 0 plus 5. Now whatever the examples we considered till now, let us try to tabulate them. Here it will be like this. And now it contains pieces per box, number of boxes, extra items, total. Ball pens, we observed that there are 4 ball pens in each packet and 5 packets, 4 into 5 plus 1, that's how we get 21. Likewise, erasers, 3 into 4 plus 2, 14. Then pencils, 15 into 3 plus 0, 45. And sharpeners, 15 into 0 plus 5, that is 5. Okay, this is the way in which we can get them. Now let us consider, suppose all the numbers are to be arranged or made into 2 groups. How can you arrange? So we can arrange them like 1, 2, 3, 4, 5, 6. In the first group contains 1, 3, 5, 7, 9, etc. Second group contains 2, 4, 6, 8, 10, etc. Right? So first group numbers we can write like 2 into 0 plus 1, 2 into 1 plus 1, 2 into 2 plus 1. Means we can observe that all the numbers are leaving remainder 1. So we can write them like 2m plus 1. On the other hand, in the second group we have all the numbers leaving remainder 0. So we can write them like 2m plus 0. So 2m plus 1 numbers are odd numbers and 2m plus 0 numbers are even numbers. In the same manner, all the numbers, instead of making it into two groups, suppose we made them like three groups. Now we get it like all the numbers leaving remainder 1, all the numbers leaving remainder 2, and all the numbers leaving remainder 3. How can it be? Now let us see. Now if we observe here, in the first group contains 1, 4, 7, 10, 13, etc. So that is 3m plus 1. Next 2, 5, 8, 11, 14, etc. 3m plus 2. And next group is 3m. Means we can observe that all the numbers leaving remainder 0 are 3m, leaving remainder 1, leaving remainder 2. So now what is the divisor and what are the possible remainders? When I take 2, I have 2 possible remainders 0, 1. When divisor is 3, we have 3 possible remainders 0, 1, 2. For 4, we have 0, 1, 2, 3 and so on. If you consider if suppose b is the divisor, we can observe the possible remainders are 0, 1, 2, etc. b minus 1. Now all the numbers, suppose if you consider like only one group, then we can say the numbers are of the form 1m plus 0. On the other hand, if you consider them like two groups, you can observe that they are of the form 2m plus 0, 2m plus 1. If they are three groups, then you can observe that they are 3m plus 0, 3m plus 1, 3m plus 2. So just if we tabulate them, b, that is divisor, remainder and forms of a. When it is 2, we have two possible remainders 0, 1. Then the forms of a are 2q plus 0, 2q plus 1. For 3, we have 3 possible remainders 0, 1, 2. And the forms are 3q plus 0, 3q plus 1, 3q plus 2. Means numbers leaving remainder 0, numbers leaving remainder 1, numbers leaving remainder 2. Likewise, for 4, we have 4 possible remainders 0, 1, 2, 3. So the forms are 4q plus 0, 4q plus 1, 4q plus 2, 4q plus 3. In the same manner, if you consider, just you can observe that for 5, you just imagine how can it be. Now we are considering if suppose it is b, we have 0, 1, 2, etc. b minus 1 are the possible remainders. So the forms will be bq plus 0, bq plus 1, etc. Finally we get bq plus b minus 1, right? Now suppose I considered 7 squares. I want to make 3 boxes like 1 unit. How many units do I get? I get 2 units and 1 box is left. The same thing we can consider, like, okay. Now here you observe, suppose you are given any two integers a and b, of course b not equal to 0. There exists unique non-negative integers q and r such that a is equal to bq plus r, where 0 less than or equal to r less than b, right? And now this is known as Euclid's lemma, means this is the name of the mathematician. Okay, and now let us try to understand the same. It is a simple process. We are very much familiar with the process of division in lower classes we learned. So here we can observe that dividend is equal to divisor into quotient plus remainder. Now you compare it with this. A is the dividend, b is divisor, q is quotient, r is remainder. So we can say a is equal to bq plus r, where 0 less than or equal to r less than b. This is known as division lemma or Euclid's division lemma, right? Now the person is thinking to himself, by using this division lemma, and now I can solve my problem. How can he solve? Just let us see. Now he arranged all the coins in the form of a square. Means the square numbers are, we know that 1, 4, 9, 16, 25, etc. Now they are distributed among 3 thieves. So apply these square numbers can be written as 3 into 0 plus 1, 3 into 1 plus 1, like that. Then we are not getting a remainder 2. Always we are getting either 0 or 1 as the remainder. So when 3 thieves are distributed the coins equally, 2 coins are left is wrong. So the God himself is the culprit. If we want to generalize the same, we write the same like this. We know that all the whole numbers can be expressed in the form of either 3k or 3k plus 1 or 3k plus 2. After squaring, we can just observe that it is in the form of some 3m or 3m plus 1 or 3m plus 1. So there is no question of getting remainder 2 when a square number is divided by 3, right? So from that easily we can understand that the God himself is the culprit. Now try these problems. Suppose you are given the square of any integer is of the form 5m or 5m plus 1 or 5m plus 4, where m is a whole number. Also, you can try the cube of any integer is of the form 4m or 4m plus 1 or 4m plus 3, where m is a whole number. Now, a small puzzle to you. A person has 3 jars of capacities 8 liter, 5 liter and 3 liters. If 8 liter jar is full of milk, then how can he distribute that milk equally for 2 persons by using the jars only with him? Right? That's all for now, guys. I am signing off. We will consider one more in our next session. Thank you.